The focus of this movie is to show how properties passed from OrCAD Capture may be used in PCB Editor. We will also cover the reuse of constraints previously saved off from a similar design and split planes and copper pores. We'll start by placing the parts that were previously assigned to the LED room. We'll place by room to automatically filter out all but the components that belong in the LED room. As you can see, we currently only have top and bottom layers defined in our StackUp. There are also no constraint sets defined except the default physical and default spacing constraint sets. We have saved off a technology file containing the constraint sets and layer StackUp from a previous design. To save time, we'll import that tech file into our place design to quickly set up the layer StackUp and enter constraint sets. Once imported, we can assign those constraint sets to our nets, net classes, and differential pairs imported from our schematic. Now we're ready to assign the constraint sets. Let's start in the electrical domain. We will assign the DP electrical constraint set to our differential pairs. This will specify the maximum allowed uncoupled length within each differential pair. Let's also check that the EC Set 2 constraint set containing total etch length rules is present on the proper nets. Next, in the physical domain, we will assign the 6 mil line constraint set to our clock net class. And we will assign the DP physical constraint set to our differential pairs. This will specify the line width and primary or ideal gap between the two members of each differential pair. In the spacing domain, we will assign a 6 mil space constraint set to the clock net class. Also in the spacing domain, we will set up a class-to-class constraint set between our DC nets and our clock nets. We just assigned a 6 mil spacing to our clock nets, while our DC nets were assigned the default or 5 mil spacing rule set. Now we will assign a 10 mil space between those two net classes. This means that if one of the clock nets is routed next to one of the DC nets, they must be at least 10 mils apart. Now that all the constraints are assigned, we can start routing. The differential pair constraints control the interactive routing. As you can see, when one member of a pair is selected for routing, they route as a pair with the assigned line width and gap between them. Once routed, we will use the slide and delay tune commands to adjust the length to meet the total etch length rule as well. We must also finish routing and adjust the nets that we're only assigned the total etch length rule. Finally, we will take the routed board and create our power and ground planes and copper pour areas. We will do the ground plane first by selecting the Edit Split Plane Create command, the ground layer, and, when prompted, the ground net. Next, we'll do the power plane, which is a split plane containing VCC, plus 12 volts, and negative 12 volts. First, we'll turn on our anti-etch layer that already contains the lines specifying where the plane will be split and how wide the split will be. We will now use the Edit Split Plane Create command again to specify the layer and each net in turn that will be assigned to the different sections of the split plane. Last, we will create a copper pour on the bottom layer for ground earth. Since ground earth is colored brown, it will be easy to see exactly where the copper pour should be. We'll select the bottom layer, the ground earth net, and then draw the polygonal shape. Adjustments to the etch inside the shape may be made without re-pouring the shape. Thanks for watching the Constraint-Driven Design with OrCAD PCB Designer Professional movie series.